Hello everybody, welcome into another lesson. So today we are going to apply everything we've learned to irrational exponents. Sometimes you will have irrational exponents. We're going to find that out in the next section of this course when we go on to study exponential and logarithmic functions. They will also come up a lot in pre-calculus and in calculus courses should you go on to take those. But it's the same properties. So you have x to the second times x to the square root of 3 power. Well, when you're multiplying the same base with different exponents, remember, you just add the exponents. So all you're going to get is x to the 2 plus square root of 3. And that's as far as we could go. You'll get x to the 2 plus square root of 3 power. Alright, now you have y to the square root of 2. That is raised to the square root of 2. So y to the square root of 2 raised to the square root of 2 power. Well, you just multiply the powers, you'll literally just get y to the second power. That's literally as far as you can get, y to the second power. Oh yeah, I should specify all variables are positive again. Alright. Now what if you had something like xy raised to the pi power? We know pi is not a rational number, right? So you'll have xy raised to the pi power. Same properties, this would just turn into x to the pi, y to the pi. And that's how you would simplify this. You would just get x to the pi, y to the pi. That's the best we could do. Now, here's an interesting one. 4 to the negative square root of 7th power. 4 to the negative square root of 7. Well, if you have a negative exponent, what's true? It becomes a positive exponent in the denominator. This would be 1 all over 4 times the square root, 1 all over 4 to the square root of 7 power. Some of you might be thinking, well, shouldn't we rationalize the denominator? Well, the radical is an exponent. It's not a normal base or expression. It's an exponent, so we really can't rationalize it. So this is the best we can do. You would get 1 all over 4 to the square root of 7 power. I have about 4 more. You'll have x to the 2 times square root of 5 divided by x to the square root of 5 power. Well, definitely 2 times the square root of 5 is greater than the square root of 5, so if you just subtract the powers, you would end up with x to the square root of 5 power. And that's the best we could do to simplify this. You'll get x to the square root of 5 power. 3 more. Now we have x to the 1 over pi divided by y to the 2 over pi power, that whole quantity raised to the pi power. So x to the 1 over pi power divided by y to the 2 over pi power, all that raised to the pi power. Well, let's do our multiplication here. You would literally just end up with x over y to the second. That's the best we could do to simplify this. You'll end up with x over y to the second. Easy enough one here. 3x to the square root of 2 power plus x to the square root of 2 power. Well, you have the same base and same power, so all you got to do is add the coefficients. You'll end up with 4x to the square root of 2 power. So this would be 4x to the square root of 2 power. And I have just one more. We have x, y to the square root of 11 power minus 3x y to the square root of 11 power. Well, you have the same bases and same exponents, so all you got to do is subtract. This would end up giving you negative 2x y to the square root of 11 power. So the same rules we've applied to rational exponents can be applied to irrational exponents. They can be applied to any exponents as long as you follow the properties of exponents. So that's it for this lesson. Next lesson, we're going to shift gears into function operations and how to add and subtract functions, multiply them, divide them, what it means for their domains, and also take composition of functions. So I hope everyone has a great day. Take care.